So now that we've got our spaceship in place for the player, let's start moving them around within the world. Now in our previous game, what we used to move around was on our paddle. We just changed the position of the paddle within the world, and what we used to move the ball around was rigid body forces, but we didn't actually control the ball. We just started it moving with some forces and it went flying off in whatever direction it wanted to. But what we're actually going to do in this game is use the rigid body forces to move the player around the world, rather than controlling specifically where it is in the world itself. They're both perfectly fine options for how to move your player around in the world. They just do some different things with how Unity handles physics, basically. So, to do that, obviously we're going to need to add a rigid body to our player. So we're going to go add component, and we're going to add a rigid body 2D. But also, in order to use a rigid body 2D, it needs to have a box collider to attach to it. So we're going to go to add component. Well, it doesn't need a box collider specifically, sorry. It needs a collider of some kind. But we're going to use a basic just box collider 2D for this object. Now our box is very big, and what could end up happening in the future when we have enemies that will shoot at our player, if they manage to hit kind of this area here when our player is moving down, if they hit the box here, then our player will take damage, but visually it won't look like they should have taken damage. So what we actually want to do, and what's a very common thing to do in these kind of games, is actually make the box a lot smaller than you would logically think it should be. So I'm going to shrink it down on the x-axis here by clicking on the x and dragging to the left, and you'll see our box gets a lot thinner, like that. And then I'm going to move it to the side by going to offset here and clicking and dragging to the left and moving it back a bit. And see now it's a little bit shorter than the ship, but it's still as wide as the ship, but that's too wide still. We want to shorten it down a bit, so I'm going to grab the Y size and pull that down a little bit, just so it goes inside the ship. So this area here is actually the full area that enemies can hit, and it adds it makes the game feel better to the players. So rather than using the full size of whatever object you're using to fly around in, just using this slight bit smaller just improves immensely how the game actually plays. Okay, so with that all done, we have a rigid body, we have our box collider. Let's go ahead and create a script to let our player be able to move around. So we're going to go in here into our scripts folder and create a new C# script that we're going to call our player controller. And we'll open this up in MonoDevelop. So once this is opened up, let's first of all give ourselves a variable to play around with, which is how fast our player is actually going to move. So we'll say public float move speed. And as we said, we're going to move the player around using the rigid body. So if we're going to use the rigid body, let's go ahead and make a reference to that. So we'll say private rigid body, we'll say DRB for the rigid body. And of course we know that if we want to be able to access the rigid body that's attached to the same object that this player controller script is, so this script obviously will be attached to our ship, and our rigid body is attached to the ship. Actually, this would be a rigid body 2D. But if we want to be able to access that rigid body, we know in the start function we have to say, okay, the rigid body that we just created should be equal to get component rigid body 2D. So that way it finds the rigid body that's attached to the same object that this script is. So perfect, now we're able to access that rigid body. So how do we make the player move within the world? Well, obviously we want to get whatever input the player playing the game is putting onto the objects. So what we could do is, as we've done previously, we set up specific keys to move up and down or left and right. But what we're going to use is actually something built into Unity that we can take advantage of that makes it a lot easier to take input in the game. So if I pop back into Unity here and if you go to edit and then down to project settings and then to input up here, you'll have this drop down over here on the right. It might be collapsed when you open it first, so you might just have axes, but just hit the little triangle to the side and then you see you get a bunch of different input options here. So we have horizontal, and that's movement on the horizontal axis, so that's moving along the x-axis left to right. We have vertical, which is moving up and down on the y-axis. Then we have some fire buttons, so that's different buttons to press to do whatever various effects you want to do. Then you can keep track of the position of the mouse on the screen, all various different stuff you can actually do within Unity. But you'll notice that we've got two horizontals here. set up. And the reason for that is if I drop down this horizontal, what this is doing is actually checking if anybody presses the left or the right arrow, or it's also checking if anybody presses A or D, which are the kind of common keyboard controls for moving left and right. And if we go down to horizontal here, what this one is doing is it's checking the joystick axis. So what it's actually checking is if there's a controller being used. So if we take advantage of using the horizontal input axis here, what that means is if we can allow players to control the game in a variety of different ways. They can control our ship using the arrows, they can control the ship using WASD, or they can potentially control the ship with a controller plugged into their computer. And it's good to give our players these options and different ways of being able to interact with the game. So we're going to use the horizontal axis, and the way we do that is, just as an example here, we're going to say, to access any kind of axis, we would say input dot get axis, and then in the bracket we just say horizontal. So we want to be able to check what input is happening on the x-axis, so making our ship move left to right. So I'm just going to delete that for a second, and we're going to decide how we're actually going to use this in our game. So the way we can do is say, okay, we can get input on the horizontal axis, which would be our x-axis. We can also get input on our vertical axis, which would be on the y-axis. So let's create a new variable, a new vector2 variable that will hold the x and y value for what input our players are apparently given. So let's go up here below our move speed, and we're going to create a new public vector2 that we'll call move input. And then at the start of our update loop, the first thing we're going to do is just say, okay, that move input we just created, move input equals a new vector2, and on the x-axis we wanted to take the horizontal input that we have over here, so we'll say input dot get axis horizontal, oh, not horizontal, horizontal, like that. And then on the y-axis we'll have it say input dot get axis vertical. So we see here we have the vertical axis, and that will allow us now to be able to take input from our players pressing up and down for vertical, or W and S, or moving the analog stick on a controller up and down. And the same for our left and right, we'll be able to move left and right and all like that. So now we're getting any input that the player is creating for our game. So let's use that input to apply some force to our rigid body. So we know if we want to use the velocity of our ship on a rigid body, we just say the rigid body dot velocity should be equal to, and what we can set it to is, we know we're going to use this move input vector2, which is taking in whatever input our player is currently pressing. So we'll say move input, and we'll just multiply that by whatever our move speed is, so how fast we want to move the ship around in the world. So let's save that and pop back into the game and see how this will work. We'll let it compile here, and we of course need to actually attach the script to the player. Once it's finished compiling, we can go down here. We're going to add this new component, our player controller. We'll give him a move speed of say 5, and we should actually make our move input private because we don't need to see that value when we're playing our game, but just for interest's sake we'll show it here while we play the game first time. And we hit press play, and now we'll see, oh well, our ship is slowly falling down because we didn't turn off our gravity scale, so I'll just do that here. But now we'll see our ship can move around within the game. And now before we go any further, we're going to have the first kind of question of game feel about our game. So if you notice the numbers on the right, so I'm not pressing anything now, and I'm going to press the button to move to the right, and you watch the Y value. So if I press the button, or sorry, watch the X value, it was the wrong one, sorry. So again, we'll just start here. So we'll watch the X value here, and we go to 1, and then it slowly goes back to 0. And what you'll notice if you watch the ship moving, as soon as you start moving, there's a little bit of a lag before the ship kind of gets going. And that's due to how we've set up our input.getAxis. So I'm just going to stop this game running here. I'm going to remember to turn the gravity back off again. So set it to 0. I'm going to go back into Unity here. And so what we've used is input.getAxis horizontal. And what this does is it basically kind of gradually moves between whatever the previous input was and whatever it currently is. And we might not necessarily want to do that. It depends on how you want your game to feel. If you like that kind of delayed kind of input and a little bit of lag, it can change how the game feels, and it can make a difference to how your game particularly feels. But if you wanted it to be very specific and it matched to exactly what the player is inputting, what you want to do is say, instead of saying input.getAxis, we want to say input.getAxis raw. And input.getAxis raw means that it'll just put out exactly what's being pressed right now. If we just use input.getAxis, it tries to kind of blend between either 0 when you're pressing nothing or 1 when a button is being pressed, and it'll kind of smoothly go between those two numbers. But getAxis raw will just go straight away from 0 to 1. So let's save this and go back into the game and see that in action. We let it compile. Let it go for a second. There we go. Now we press play. So this time keep an eye on the x-axis again, and at the moment it's 0. If I press the button, straight away it just goes to 1. And you can see now on our screen the ship is moving exactly with how I press. There's no delay, there's no like little boosts as it goes and kind of a feeling of weight, but you get a much more sense of control. So you're kind of sacrificing, hey, if we do the other way, our ship kind of feels like it has a bit of weight and momentum, but if we do it this way, we have very specific and tight control to the game. So as I said, it's all down to personal preference and how you want your game to feel. So feel free to either use getAxis raw or just getAxis.